welcome to the Head Starter Accelerator project number 1. This is the customer churn prediction model. Essentially what it does is it takes in a data set or a number of inputs on a customer for a bank, and it will print out the probability of that customer for them to churn, aka leave the bank or not remain loyal to the bank. Now, there are a lot of moving parts to this project, but generally it's pretty straightforward. We take in the dataset churn.csv. This is available on Kaggle. And then we pre-process the data to make it a little more digestible for a certain model. And then we train those models based on our new dataset. So I can just go ahead and run all these cells. So very generally, the first part of this Jupyter Notebook file is all about pre-training the model, pre-processing the data, and then making it more digestible for both the model and, I need to upload churn.csv. Give me a second. Yeah, so basically, it's quite simple. It uses a lot of machine learning techniques, but techniques that are quite essential. So if I upload churn.csv here, and then I run all these cells. So pandas is required. A lot of imported libraries are required. And this is basically our raw data, right? This is what we obtain directly from Kaggle. So row number, customer ID, surname, blah, blah, blah. And based on this data set, our model or models are going to predict based on, a number of factors such as balance, estimated salary, surname, how likely they are to churn from our bank. Now, each model is different. They're going to be trained differently. They're going to be focused on different things. But in general, what we're looking for is accuracy and recall. So we can skip over all this. Now, something that's interesting is distribution of churn. So this is one example of a skewed data set. So we know that we're going to have a lot more cases in which a customer does not exit the bank as opposed to customers who do exit the bank. So naturally our data set is skewed in distribution, and we need to kind of normalize it or stagnate it so that our AI models can more effectively understand what parts are more influential in causing a customer to churn. So yeah, we can blast by a lot of those data manipulation stuff. And here we get to the training. So we're splitting up the training into 80% train and 20% test. So we're taking 80%, aka 8,000 customers, training the data set, training the AI models on 8,000 rows of the data set, and then testing it on the other 2,000. And here we're using random state 42 42 just to have a consistent seed so that every time we have an output, it will remain the same. But of course, we can just get rid of that random state and then it'll be perfectly random. So we use some techniques such as scaling. And here we can import a lot of different machine learning models that will focus on different things, such as the decision tree classifier. And a little further down, we're going to have the voting classifier, which kind of just puts things at a 0 and 1 value. But it's just an example of what different models will do or what different models will focus on. One thing that's pretty interesting is that we can produce more data from our data set, such as age group, tenure-age ratio, which is a relation between tenure and age, obviously, and then CLV, which is a relationship between balance and estimated salary, obviously. What would it be? So we can also fine-tune models such as SMO, which is fine-tuned based on the XGBoost model, and then voting classifier, right? So yeah. So for this notebook, all it really does is it takes in the data set we manipulate the data set quite a bit so we can get a more even distribution of data, and then it spits out a number of models that we tell it to train. So moving on to the next part, now that we have our AI models, we can move to the front end part of the project, which is essentially creating a web view. Sorry, it says offline right now. I'm having a couple connection problems. But it'll basically spit out a website that presents to a user the data that we have, um, based on individuals in the data set, such as the first name that will pop up is the default Hargrave, and they each have individual um, unique things about their data, such as age, balance, geography, and essentially what the website is doing is that it'll load in every single model, and then based on those models, it'll spit out the prediction of each model, and then the average prediction overall of the likelihood that user is going to churn. That sucks. Well, it'll come right back. And then at the very end, below the graphic that shows the prediction, we're going to use something in Grok. So what I used was Metalama 3. Sorry, where'd it go? Metalama 370B. Let's ignore that. And it's just an LLM that takes in the prompts that I've typed in here, and then it'll spit out a nice explanation that seems natural enough that it's not like a really weird AI just speaking. It feels like some manager is just a data analyst at this bank. So let's wait for this to load. And here we have it, right? So at the top, we have the customer churn prediction, obviously. We have the customer, and each customer has their own preset values because of our data set, churn.csv. But we can also adjust these credit scores, adjust these numbers, and it will change the probability based on it. So let's change this to something like 40,000. And what's the probability it's going to churn? Yeah, that's currently running, so we'll just give that a second. But if we move on, skip ahead a little bit, we have the explanation of the prediction that seems quite believable. It's specific enough, it'll mention certain data, pieces of data, and it seems very personalized. And then we have a personalized email. So this is an AI generated or an LLM generated response email that has the hope in mind of incentivizing customers at risk of churning to stay with our bank, right? And then for now, I only have random forest and XP boost, but if we can go back in, oops, that's okay. But if we go back in, we can probably add a couple more models, and then this probability will change as well because each model has its own way to predict churn probability. So yeah, that's about it for this project. Thank you for watching.